Yesterday we were discussing about the state space models. What is the difference between state space model and the transfer function is that transfer function can have only one single input and one single output. So you can use transfer function only for such cases. If you have multiple inputs and multiple outputs, you need to have many transfer functions. So that will make the control system design difficult. So in order to make it simpler, what you use is a state space model. So this state space model is full of matrices which can contain many number of inputs and outputs. Okay, so it's very much suitable for the multiple input and multiple output kind of systems. So it has a better advantage compared to the transfer functions, which can handle only the single input and single output. But if you use multiple transfer functions, more than one transfer functions, then you can also design for the multiple input and multiple output, but that becomes a little tedious. Okay, so that's why you use state space models. So the basic idea about the state space models is that you need to know what are the state variables. State variables are the ones which define the complete system. Okay, so in the case of this spring mass damper system, if you want to define the system completely, you need to know its position and velocity. If you know its position and velocity, then you can define everything else. Okay, what is the remaining thing? Acceleration. So you can find acceleration from the position and velocity. So this example has two state variables, that is position and velocity. So what you do is you define the position x of t is equal to x1. You define the velocity x dot of t is equal to x2. So x2 will be equal to x1 dot. And u of t is the force that is applied on this system. So u of t is equal to u1, and x double dot of t is x2 dot, because x dot of t is equal to x2, so x double dot of t is equal to x2 dot. So this u of t, from where do you get this? This is from the Newton's second law. Okay, u of t minus kx minus ex dot is equal to mx double dot. So since you have this written down, you frame that in this form. Okay, and then x2 dot will be equal to this, x1 dot is this. So you write in the form of x1, x2 and u for the x1 dot and x2 dot, and then you bring it in the form x dot is equal to ax plus bu. So you separate that out in this form, ax plus bu form, and then you write down what is a, what is b, and the other equation is y is equal to cx plus du, where y is the output, y is equal to x of t. So here there is only one x1, okay, and this is 0 and this is 0. So y is equal to x of t, which is equal to x1. So y is equal to x1. So because of that, c is only 1 and 0, okay, and then d is 0 here. So there are two equations, x dot is equal to ax plus bu and y is equal to cx plus du. So in these two equations define the state space model of the system. And then what did we do? We took the transfer function of that spring mass damper system. So this was 1 divided by 3s square plus 2s plus 1. We just plugged in some values and got this 1 divided by 3s square plus 2s plus 1, where m is equal to 3, c is equal to 2 and k is equal to 1. So in the MATLAB, when we did that, what is the command for changing from state space to transfer function? What was the command that we used? This is the one, ss2 tf, ss2 tf. Okay. So if you want O grades, if you want A plus grades, you must have communicated in the class. If not, then you will not be getting it, because there are points for communicating in the class also. Okay. Fine. So now what we do is we saw what is a state space model, and we'll convert state space model to transfer function. I'm very serious. If you don't communicate, you'll be losing marks. So this O grade and A plus grade will be in trouble if you don't speak. Others, it's okay. Others, 1 grade less, they don't mind. But those who need the O grade and A plus grade have to speak. If a B plus gets C, that student wouldn't mind much. Okay, state space model to transfer function. Why is this required? Any idea? What will be the use of this? Okay, no.
So hello.
Yeah, tell me.
So state space model known as multiple point solution, like we have input and multiple.
Okay.
We are converting it to single output, single input and single output.
You can solve these like individually, sir.
Okay.
Of doing multiples at once.
Okay. The use of state space model is to design a controller for multiple input, multiple output systems. Okay. But why we are converting from state space model to transfer function is just to show that there is a relation between the two. Okay. The use of state space model is to design controllers like PID controllers, some other controllers we want to design. Okay. So for that we use state space model. But if you there is no real application of converting state space model to transfer function. Okay, we don't want to use this transfer function model. Okay, we want to use state space model for designing controllers. But in order to show that there is a relation between state space model and transfer function, we just do this. Okay, so it doesn't have a real application. So just to show that there is a relation between the two, we do this. But real use of this state space model is when you develop a controller. Okay, fine.
Sir, is this like reduction of blocks?
No, this is not reduction of blocks. This is a differently. This is a totally different method compared to the transfer functions. Transfer function has this output.
Yeah.
Output. Okay.
Yes, sir.
But state space model has A matrix, B matrix,
Matrix, C matrix, yes, I got it.
and D matrix. Okay.
But
So
is it similar to that? The way of
there is a relation. There is a relation. That's all. There is a relation between this and this one.
Okay.
Okay. It's not
Okay,
the
okay.
same. It's not the same. The matrix, it uses matrices. Okay. So that's why
Oh.
it has state space model, and it uses matrices, and this has a relation with the transfer function, but these two methods are completely different.
Okay, so okay.
The purpose of transfer function is also to design a controller for that system. The purpose of the state space model is also to design a
To design
controller for that system. Okay, the purpose is the same, but the approach is different.
Okay, so okay, got it. Sir.
Okay. X dot is equal to AX plus BU. Y is equal to Cx plus du. These are the two equations in the state space model. Now what we are going to discuss is what is the relation between state space model to transfer function. How to convert from state space model to transfer function. What is the relation? Okay. So for that we need to take the Laplace of these two equations. Okay. So what will be the Laplace of x dot? It will be s into x of s.
S into X of S.
Okay, a into x of s plus b into u of s. The second equation, if you take it as y of s is equal to c into x of s plus d into u of s. So this is, call this as equation 1, call this as equation 2. Now solve equation 1 for x of s. Okay, solve equation 1 for x of s. So how do you do that? Is s into x of s, this equation, I take ax of s this side, so it is minus ax of s is equal to what will it be? What is sx of s minus ax of s? A is a matrix. Okay, A is a matrix. S is not a matrix. So how will you minus this to? Use a, what do you use? Use the identity matrix for that. Okay, multiply S with the identity matrix. Okay, minus A x of S is equal to B U of S.
U of s.
Okay, so you need to, why this identity matrix is there? Because you need to subtract these two. Okay, for that you multiply this S with identity matrix. Okay, now you have this S I minus A x of S is equal to Bu of S. Okay, so for this you multiply both sides with S I minus A inverse. Okay, Si minus A inverse into Si minus A x of s is equal to Si minus A inverse Bu of s. Okay, I multiplied Si minus A inverse both sides. Okay, so can I cross this? What is Si minus A inverse into Si minus A?
It is 1, sir.
One, sir.
Okay, so I'll just cross this out, cross these two. Okay, so what will be x of s equal to? So x of s is equal to
S, sir.
Si minus
Si
A,
Si minus A
the whole inverse
into
Bu of s.
s.
Okay, so this is the thing. Now y of s is equal to, y of s was equal to what? C into x of
U of S.
Okay, so substitute, I'll just write down the equation again. C into x of s, what was y? Okay, C into x of s plus
Plus d into
U.
u of s. Okay, so what you do is y of s is equal to C into, in place of x of s, put this. Okay, put this Si minus A inverse Bu u of s, then the whole thing multiplied by x of s plus d u of s. Okay.
Yes, sir.
Okay. So what will you get for y of s by u of s? What is y of s by u of s? Y of
Sir,
s output.
in the above equation, we should not be, there should not be s of x.
Where? Okay.
Ah, yeah, that part.
Yes, so that won't be there.
Okay, fine. So what is y of s by u of s? Y of s is the output. U of s is the input force. Okay. So this is equal to what?
See,
Into Si minus
minus
A inverse B, okay, plus
Plus
B.
B.
okay. So this is this a transfer function?
Yes, sir.
So that
This
is
is a
the,
transfer function,
yes.
and this is how the transfer function and the state space model is related. Okay, it is related by C into Si minus A inverse B plus D. Okay, so this is the relation of transfer function with the state space model. Okay, so what did we do? We just wrote these two equations, the state space model equations, and then took the Laplace of these two, took the Laplace, and then solve for x of s in the first equation. Okay, here this identity matrix is because this is only one number and this is a matrix, so for that you multiply with the identity matrix and then take inverse both sides. This and this gets cancelled. X of s is equal to Si minus A inverse Bu of s. So from the second equation you write this second equation, y of s is equal to Cx of s plus du of s. Y of s is equal to C into, put this x of s, this one, plus du of s. Take the transfer function, that is y of s is the output, u of s is the input. Okay, according to, you understand this, right? So where is the spring mass system? Yeah, u of s is the applied force. Okay, x of s is the
Displacement of the
displacement.
mass.
Okay, so for that output is y of s is equal to x of t. Okay, y of t is equal to x of t, so y of s is the output. So y of s by u of s is equal to this one. Okay, so this is output by input. This is how this is the state space model, this is the transfer function. So this is the relation between the two. Now if we see, the purpose of this is just to show what is the relation between transfer function and state space model, but with a state space model you don't convert it to transfer function. Okay, the purpose of state space model is to design a controller. Okay, we'll see how to design a controller a little later, but I'm just trying to show you the relation between state space model and transfer function. Suppose a matrix A is given 0, 1, 2, minus 3. Okay, B is equal to 1, 0, C is equal to 1, 0, D is equal to 0. Till we design a controller, you will not be fully able to appreciate the state space model. So you'll have to wait for that for a few classes. Okay, so this is ABCD matrix. Okay, now I want to know what is the transfer function of this. Okay, so how am I supposed to do this? So use the formula C into Si
Yes,
minus A inverse B plus D. Okay, so what is C? It is 1.
1, 0.
What is Si? What is Si? How do I write Si?
Oh, sorry, S0.
S00.
S0
S0
0
0 S.
S. Okay. Minus A.
0 1 2.
0, 1,
0 1 2
minus
minus
3.
3. Okay. So take the inverse of that and then multiply it by 1 and 0 plus 0. Okay. What do you take? So we'll just work on this part alone. Okay. What is take the minus of this? It is
S,
S
S
S
minus
minus
1
1
minus 2
minus 2,
minus 2
S plus 3.
minus 3.
S
S
plus 3.
plus
Okay. Now we need to take the inverse of this. What will be the inverse of
The rows become columns and columns.
yeah, minus 2 S plus 3? Inverse you take, it will be
S minus 2
um,
1 S plus 3.
these two have to be interchanged, correct? S plus 3, you put S here, you change the sign of these two, 1 and 2 divided by determinant. Okay, S into S plus 3 minus 2. Okay, this is a shortcut of taking the inverse. Just change the position of these diagonal elements. S plus 3, put S here, change the sign of this diagonal. Okay, 2 and 1. Okay, so what you get is so what will be this? This will be
Divided by S into S
square plus 3s
minus.
minus 2.
okay, s square plus 3s minus 2. Now in the next slide, what I do is I'll just take 1 divided by s square plus 3s minus 2 outside. So what am I left with? I'm left with 1 0.
1, 0.
Okay, I'm left with 1 0 and then what else?
S plus 3,
I'm left with s plus 3 1
2S.
2s. Okay, s plus 3
1,
was that 1
2S.
and s 2 and s. Okay, and then
P.
1 0.
1 0.
Okay, so what is this? What will I get?
Uh,
S plus 3
plus 3.
0 into 2. Okay, 1 into 1
Yeah.
0 into s. Okay, you get s plus 3, s plus 3 and 1. Okay, and then 1 0. What is this?
S plus
Again S plus 3 and 0.
S plus 3 and 0. Okay, I write it as s plus 3. Okay,
divided by
divided by
Divided by S square plus
s
Square.
square plus 3s
minus 2.
minus 2. Okay, so this is the transfer function. Understood? So
Yes, sir.
given a state space model A, B, C, D, you are trying to find the transfer function. So this is the relation which we derived. Okay, we just applied this and got the transfer function to be this one, s plus 3 divided by s square plus 3s minus 2. So we'll just check it with the MATLAB if we have done it correctly. So here I'll just enter the A matrix. A matrix is 0, 1, 2, minus 3. Okay. Then B is equal to 1, 0. Okay. C is equal to 1, 0. D is equal to
0.
0. Okay, so next I say G is equal to SS means state space. Okay, SS means state space, so that will take ABCD. Okay, and then it will take the numerator and the denominator from this state space to transfer function. This is the command SS to.
This is 2TF.
Okay, so that is the conversion from state space to transfer function of this ABCD matrices. So once you get the numerator and denominator, how do you get the transfer function? So transfer function is with this numerator and the denominator. Okay, so if I run this, I get s plus 3 divided by s square plus 3s minus 2. Okay, so this is what we got here, s plus 3 divided by s square plus 3s minus 2. So, so this is the numerator, this is the denominator of that. Okay, so this is what we entered, ABCD, and then it gave the state space model of that ABCD. Okay, and then it gave the transfer function s plus 3 divided by s square plus 3s minus 2. So what we have done is we have just converted the state space model to transfer function. Okay, so you have to understand that these are the two equations, main equations for the state space model. You have to have it in this form where A, B, C, and D are the matrices. Okay, so you can have multiple input and multiple output, but we are still dealing with. Why is that only one transfer function has come? Because we are still
So
dealing.
they taken it as a single input and single.
The example what we took is still a single input.
Single input, single.
Okay, and this matrix also, what the question what we have got is still a single input, single output system. Okay, so what I told you was we can handle multiple input and multiple output in a state space model, but we have not gone to that level of solving multiple input and multiple output. Okay, I'm still using single input, single output only, but in state space model. Okay, so when we use the multiple input, multiple outputs, you will understand better